Welcome, my friend. Welcome to this peaceful moment we're sharing together tonight. I'm so glad you found your way here, to this quiet corner of the universe where time moves differently, where stories unfold as gently as starlight touching your window. Tonight I have something truly extraordinary to share with you. Something that might change how you see every mountain, every hill, even every tiny pebble you've ever held. Did you know that Mount Everest, the highest peak on our planet, contains the remains of ancient sea creatures at its summit? It's true. Climbers have found seashells and fossils of tiny ocean animals frozen in limestone, nearly 6 miles above where any ocean exists today. These weren't carried there. No. The mountain itself was once the bottom of an ancient sea, and it was built, grain by sand and shells and the patient work of microscopic life. And you know what's beautiful about sharing this journey with you tonight? If you're finding some peace in these words, if this gentle story is already helping you settle, I'd be so grateful if you'd tap that like button. It's just a little way of saying these quiet moments matter. And maybe, if you'd like more of these cosmic journeys, you could subscribe. Become part of our little constellation of dreamers. I'd love to hear in the comments too. What mountains have you climbed in your dreams? What peaks call to your sleeping mind? But there's no pressure at all. We're just here together, you and I, sharing this ancient story. Now let's begin to settle in, to prepare for this incredible journey backwards through time. Take a breath with me, a deep mountain breath, because tonight we're going to breathe with the mountains themselves. You see, mountains do breathe. They inhale when they rise, pushing up from the earth over millions of years, and they exhale as they erode, releasing themselves grain by grain back to the sea. Feel your own breath now, gentle and easy, matching the ancient rhythm of stone. As you breathe in, imagine the slow rise of limestone peaks. As you breathe out, feel the patient erosion of wind and rain. This is the rhythm we'll follow tonight, the breathing of deep time, where a single inhale might last 10 million years, and an exhale might carry the dreams of ancient oceans. Your body is already beginning to understand this rhythm, already syncing with the slow pulse of geological time. Every muscle can soften now, like sand settling on an ocean floor. Every thought can slow, like the patient accumulation of sediment. You're safe here, held by the same forces that built mountains from sand. Tonight's journey is unlike anything we've done before. We're going to start at the top of Mount Everest, right now, in this very moment. And then we're going to travel backwards, watching time reverse, seeing the mountain slowly, lower, rocks unform, stones dissolve back into sand. We'll witness the great peaks of the world return to their birthplace, ancient seabeds where tiny shells accumulated one by one, where microscopic creatures built tomorrow's mountains without ever knowing it. This is a story of transformation that's been hidden in plain sight. Every limestone cliff you've ever seen, every marble statue, every piece of chalk, they all contain the remains of ancient life. Creatures that lived and died in warm seas hundreds of millions of years ago. Their shells and skeletons became sand. That sand became stone. That stone was pushed up into mountains, mountains that wear away back into sand. completing an eternal cycle. We'll discover how pressure can transform sand into diamonds, how every pebble in your garden might have traveled thousands of miles, how the Himalayas are still growing today, pushed up by India's slow collision with Asia, adding about 2 inches every year, still inhaling after all this time. But we won't rush through this story, no. We'll move as slowly as the mountains themselves, letting each moment unfold like geological layers. Each revelation settling gently into your mind like sediment on the ocean floor. And as we travel deeper into the past, as we move further back through time, you'll find yourself sinking deeper into rest, into that timeless place where mountains dream. The journey begins now, at the highest point on Earth, where the air is thin and the sky touches space, where ancient seashells rest beneath eternal snow. Let's go there together. Let time begin its gentle reversal. Let the mountain tell us its secret story. Here you are, standing at the summit of Mount Everest, 29,032 feet above sea level. It's a place so high that jet streams sometimes brush against the peak, where the curve of Earth becomes visible, where you're literally standing at the edge of our planet's breathable atmosphere. The summit beneath your feet isn't what you might expect. It's not granite or volcanic rock. No, it's limestone, ancient seafloor limestone. And if you were to kneel down, brush away the eternal snow with gentle fingers, you'd find something that seems impossible. There, frozen in the rock at the roof of the world, are the shells of creatures that once lived at the bottom of the sea, crinoids. They're called ancient sea lilies that weren't plants at all, but animals, filtering tiny particles of food from warm ocean waters. There are trilobites too, those curious 3-lobed creatures that scuttled across sandy seafloors 400 million years ago, and tiny spiral shells called ammonites, ancestors of today's nautilus. Their perfect mathematical curves preserved in stone nearly 6 miles above where any ocean exists now. Feel the mountain breathing beneath you. That slow, patient inhale that's been going on for 50 million years. The Himalayas are still rising, still breathing in, pushed up by the endless slow-motion collision of India with Asia. Every year, Everest grows about the height of a pencil. Though wind and weather erode almost the same amount, it's a living system, always changing, never still. The limestone you're standing on, it's made of countless tiny skeletons. Each one was once a living creature floating in the Tethys Sea, that ancient ocean that existed between continents. Every grain of sand that formed this rock was once part of something alive, breathing, feeding, reproducing in warm waters where dolphins' ancestors swam and the first coral reefs grew. Look closely at the rock. Closer still. You can see the layers, like pages in a book written by time itself. Each layer represents thousands of years of accumulation. Tiny shells falling like snow through ancient waters, settling, compressing, slowly turning to stone. The mountain is literally built from death becoming architecture, life transformed to landscape. The summit pyramid of Everest, that final rocky pinnacle, it's tilted at a gentle angle, and that tilt tells a story. These layers were once horizontal, laid down flat on an ocean floor. But as India pushed northward, as continents collided in super slow motion, These seafloor sediments were pushed up, folded, tilted, lifted mile after mile into the sky. You can trace the story with your finger, following the layers as they angle up toward space. Each line in the rock is like a tree ring, marking time, marking change, marking the patient accumulation of sand and shell and sediment. Some of these layers contain dark bands, ancient storm deposits where underwater avalanches of sand cascaded down submarine slopes. Others are pure white, almost crystalline, where calm seas allowed only the finest particles to settle. The wind up here carries tiny particles of the mountain away. Each gust takes a few grains of what was once sea floor, carries them eastward. Some of that sand will travel all the way to the Amazon rainforest, fertilizing jungle soil with minerals from the highest place on Earth. The mountain is always giving itself away, always exhaling, even as it continues its ancient inhale. Now, let's begin to reverse time. Let your mind shift into that space where clocks run backward, where effect comes before cause, where mountains lower instead of rise. Feel the first subtle shift. The wind begins to blow differently, not carrying sand away, but bringing it back. Each particle finding its exact place, reattaching to the stone it left. The summit begins to lower, so slowly you can barely perceive it. An inch per year running backward, then 2 inches. The pencil height of growth that happened this year gently reverses. The mountain exhales in reverse, drawing itself down. The peak that touched 29,032 feet becomes 31, then 30, then 29. Watch as the weather patterns begin to change. Clouds that once dropped snow now lifted away. Each snowflake rising back into the sky, uncondensing, becoming vapor, becoming nothing. The permanent ice cap begins to shrink, not melting, but simply reversing its formation. Ice crystals separating, returning to the clouds they came from. Years are passing backward now. Decades, centuries. The paths carved by countless climbers begin to fade, their footprints filling in, rising back to level. The prayer flags they placed disappear one by one, lifting away on the wind, flying backward to the valleys they came from. The mountain is cleaning itself, erasing human presence, returning to its ancient solitude. Feel yourself settling deeper as we sink backward through time. The 20th century unreels. The 19th, Everest loses its English name, becomes Chomolungma again, then loses even that, becoming nameless, unknown, unclimbed, undreamed of by human minds. The Ice Age glaciers that carved the valleys around Everest begin to retreat, but not downhill. They flow backward, uphill, their mighty rivers of ice reversing course. The deep valleys they carved begin to fill. The sharp ridges they sculpted soften, become rounder, gentler. The mountain is remembering an earlier shape, an earlier time. 1,000 years pass in a breath, 10,000 in a heartbeat. The mountain continues its slow lowering. 29,000 feet becomes 28,000, then 27. The limestone layers begin to show different fossils, older ones, stranger ones, creatures that lived in even more ancient seas. The tilt of the summit pyramid begins to decrease, degree by degree. The layers of rock are slowly returning to horizontal, remembering their original position on the seafloor. The tremendous forces that pushed them skyward are weakening, reversing. The The great collision that built the Himalayas is beginning to undo itself. We're moving faster now, backward through millions of years. The mountain breathes out in reverse, lowering, softening, returning. Each layer of limestone peels away like pages turning backward in that great book of stone, revealing older chapters, older stories, older sand. Here you are, standing at the summit of Mount Everest, 29,032 feet above sea level. It's a place so high that jet streams sometimes brush against the peak, where the curve of Earth becomes visible, where you're literally standing at the edge of our planet's breathable atmosphere. The summit beneath your feet isn't what you might expect. It's not granite or volcanic rock. No, it's limestone, ancient seafloor, limestone. And if you were to kneel down, brush away the eternal snow with gentle fingers, you'd find something that seems impossible. There, frozen in the rock at the roof of the world, are the shells of creatures that once lived at the bottom of the sea. Crinoids. They're called ancient sea lilies that weren't plants at all but animals, filtering tiny particles of food from warm ocean waters. There are trilobites too, those curious three-lobed creatures that scuttled across sandy seafloors 400 million years ago, and tiny spiral shells called ammonites, ancestors of today's nautilus. Their perfect mathematical curves preserved in stone nearly 6 miles above where any ocean exists now. Feel the mountain breathing beneath you. That slow, patient inhale that's been going on for 50 million years. The Himalayas are still rising, still breathing in, pushed up by the endless slow-motion collision of India with Asia. Every year, Everest grows about the height of a pencil, though wind and weather erode almost the same amount. It's a living system, always changing, never still. The limestone you're standing on, it's made of countless tiny skeletons. Each one was once a living creature floating in the Tethys Sea, that ancient ocean that existed between continents. Every grain of sand that formed this rock was once part of something alive, breathing, feeding, reproducing in warm waters where dolphins' ancestors swam and the first coral reefs grew. Look closely at the rock. Closer still, you can see the layers, like pages in a book written by time itself. Each layer represents thousands of years of accumulation. Tiny shells falling like snow through ancient waters, settling, compressing, slowly turning to stone. The mountain is literally built from death becoming architecture, life transforming into landscape. The summit pyramid of Everest, that final rocky pinnacle, it's tilted at a gentle angle, and that tilt tells a story. These layers were once horizontal, laid down flat on an ocean floor. But as India pushed northward, as continents collided in super slow motion, these seafloor sediments were pushed up, folded, tilted, lifted mile after mile into the sky. You can trace the story with your finger, following the layers as they angle up towards space. Each line in the rock is like a tree ring, marking time, marking change, marking the patient accumulation of sand and shell and sediment. Some of these layers contain dark bands, ancient storm deposits where underwater avalanches of sand cascaded down submarine slopes. Others are pure white, almost crystalline, where calm seas allowed only the finest particles to settle. The wind up here carries tiny particles of the mountain away. Each gust takes a few grains of what was once seafloor, carries them eastward. Some of that sand will travel all the way to the Amazon rainforest, fertilizing jungle soil with minerals from the highest place on Earth. The mountain is always giving itself away, always exhaling, even as it continues its ancient inhale. Now, let's begin to reverse time. Let your mind shift into that space where clocks run backward, where effect comes before cause, where mountains lower instead of rise. Feel the first subtle shift. The wind begins to blow differently, not carrying sand away, but bringing it back. Each particle finding its exact place, reattaching to the stone it left. The summit begins to lower, so slowly you can barely perceive it. An inch per year running backward, then 2 inches. The pencil height of growth that happened this year gently reverses. The mountain exhales in reverse, drawing itself down. The peak that touched 29,032 feet becomes 31, then 30, then 29. Watch as the weather patterns begin to change. Clouds that once dropped snow now lift it away. Each snowflake rising back into the sky, uncondensing, becoming vapor, becoming nothing. The permanent ice cap begins to shrink, not melting but simply reversing its formation. Ice crystals separating, returning to the clouds they came from. Years are passing backward now. Decades, centuries. The paths carved by countless climbers begin to fade, their footprints filling in, rising back to level. The prayer flags they placed disappear one by one, lifting away on the wind, flying backward to the valleys they came from. The mountain is cleaning itself, erasing human presence, returning to its ancient solitude. Feel yourself settling deeper as we sink backward through time. The 20th century unreels, the 19th. Everest loses its English name, becomes Chomolungma again, then loses even that, becoming nameless, unknown, unclimbed, undreamed of by human minds. The Ice Age glaciers that carved the valleys around Everest begin to retreat, but not downhill. They flow backward, uphill, their mighty rivers of ice reversing course. The deep valleys they carved begin to fill. The sharp ridges they sculpted soften, become rounder, gentler. The mountain is remembering an earlier shape, an earlier time. 1,000 years pass in a breath, 10,000 in a heartbeat. The mountain continues its slow lowering. 29,000 feet becomes 28,000, then 27. The limestone layers begin to show different fossils, older ones, stranger ones, creatures that lived in even more ancient seas. The tilt of the summit pyramid begins to decrease, degree by degree. The layers of rock are slowly returning to horizontal, remembering their original position on the seafloor. The tremendous forces that pushed them skyward are weakening, reversing. The great collision that built the Himalayas is beginning to undo itself. We're moving faster now, backward through millions of years. The mountain breathes out in reverse, lowering, softening, returning. Each layer of limestone peels away like pages turning backward in that great book of stone, revealing older chapters, older stories, older sand. The ice ages are unwinding now, not just the last one that ended 12,000 years ago, but all of them, reaching back through time. The great glaciers that once covered vast portions of Earth are flowing backward, They're mile-thick sheets of ice lifting away from the land, rising back into the sky as vapor, disappearing into ancient atmospheres. Watch as the valleys around Everest transform. Those deep U-shaped canyons carved by glacial ice begin to fill and rise. The sharp, knife-edge ridges that mountaineers know so well, they're softening. The brutal landscape that challenges climbers is becoming gentler, rounder, more forgiving, though still magnificently tall. The Khumbu Glacier, that river of ice that climbers must cross, it's retreating upward now. The infamous icefall with its deadly crevasses is sealing itself, each crack zipping closed like a zipper running backward. The chaos of tumbled ice blocks reassembles into smooth slopes. The glacier is remembering its youth, when it was just snow, when it was just clouds. You can feel the rhythm of the ice ages, like the mountain's deeper breathing. Each glacial period is an inhale, ice accumulating, valleys carving, then an exhale as the ice retreats. But we're watching all the exhales become inhales. All the inhales become exhales. The mountain is breathing backward through time. 2 million years ago now, before humans walked upright. The Himalayas are still the highest mountains on Earth, but they're different, younger, less carved. The peaks are broader, more massive. They haven't been sculpted yet by millions of years of ice and wind. The monsoons that bring snow to these peaks are weakening, reversing. The weather patterns that built the glaciers are shifting backward. The very climate of Earth is changing in reverse. Warming periods becoming cool. Cool periods becoming warm. The mountain is experiencing seasons backward. Winters becoming autumns, becoming summers, becoming springs, becoming winters again. Feel how this backward breathing affects everything. Rivers are flowing uphill, carrying sediment not away from the mountains, but toward them. Each grain of sand that was eroded away is finding its way home, returning to the exact spot it came from. The mountain is rebuilding itself, grain by grain, breath by breath. The Tibetan Plateau, that vast high country north of Everest, it's lowering too. This whole region of Earth's crust is sinking back down. The uplift that created the highest plateau on our planet is reversing. What was pushed up is settling back. What was raised is lowering. The roof of the world is coming down. 5 million years backward now. Everest is only 20,000 feet tall. Still impressive, still mighty, but no longer the highest point on Earth. Other peaks hold that honor. Peaks that in our time have already worn away. Mountains whose names we'll never know because they'll be gone before humans evolve to name them. The rocks are changing. The limestone layers are thicker, less fractured, less weathered. They remember being younger, remember being stronger. The fossils within them are different too. More primitive creatures, simpler shells, older forms of life that lived in even more ancient seas. 10 million years ago. The mountain is half its modern height, maybe 15,000 feet. The collision between India and Asia that pushes up the Himalayas is younger, less advanced. India is further south, still moving backward across the Indian Ocean, retreating from its destined collision. You're breathing with the mountain still, that slow rhythm. Inhale, exhale. But each breath now spans millions of years. You're sinking deeper into geological time, into that place where human lifespans are less than a blink. where civilizations rise and fall faster than a single grain of sand can form. Now we reach the layers themselves. Watch as the limestone begins to peel away. Layer after layer, like an onion being unwrapped. But each layer is millions of years thick. Each one tells the story of a different ocean, a different time, a different world. The youngest layers go first, the ones at the very top. These formed in the Tethys Sea just before it closed, when the ocean was narrow, squeezed between approaching continents. The creatures in these layers are almost modern, ancestors of fish and shells we'd recognize today. As these layers peel away and dissolve, they release their memories back to the sea. Deeper layers now, older limestone. The fossils change, become stranger. Creatures that have no modern descendants. Experiments in life that didn't survive to our time. Shells with bizarre geometries. Fish with armor plating. Squid-like creatures in coiled shells as large as truck tires. 20 million years ago, 30 million, the limestone is unforming. The pressure that turned sand and shells into solid rock is releasing. What was compressed is expanding. What was solid is becoming loose, becoming soft, becoming sand again. Can you feel how the very atoms in the rock are relaxing? The calcium carbonate crystals that make limestone, they're loosening their bonds. The geometric patterns that create solid stone are dissolving, returning to their original state as tiny particles, as dissolved minerals, as the substance of shells. Each fossil is unfossilizing. The minerals that replaced the original shell material are reversing their replacement, exchanging back. The perfect preservation is undoing itself. Shells that were stone are becoming calcium again, becoming the actual shells they once were. 40 million years ago. The mountain is just a broad hill now, maybe 5,000 feet, covered not with snow but with tropical vegetation. The climate here is warm, humid. Palm trees grow where glaciers will one day form. The limestone layers continue peeling away, each one returning its sand to ancient seas. The collision between India and Asia is barely beginning, just the first gentle touch as the continents meet. India is still an island, still surrounded by ocean, still moving backward across the waters. The Himalayas exist only as a low ridge, a wrinkle in Earth's crust, a suggestion of what they'll become. 50 million years ago, the limestone that will become Everest is still on the seafloor. It's not a mountain at all, not even a hill. It's just layers of sediment beneath warm tropical waters. The sand and shells are still accumulating, but in reverse now. Each grain lifting off the seafloor, rising up through the water, returning to the creatures that created them. The entire Himalayan range is shrinking now, not just Everest. Every peak from K2 to Kanchenjunga, from Lhotse to Makalu, they're all lowering together, all breathing out in unison. The Great Wall of Mountains that separates India from Tibet is becoming smaller, gentler, more like a series of rolling hills. Watch as the mountain chain smooths out. The sharp peaks that pierce the sky are rounding. The jagged ridges are softening. It's like watching wrinkles disappear from fabric as someone slowly irons it flat. But the iron is time itself. And each pass takes 1,000,000 years, 60 million years ago. The Himalayas are just a low mountain range, like the Appalachians are today. Worn, ancient looking. even though in this backward flow of time they're actually getting younger. Their peaks might reach 8,000 feet, maybe 10,000 in places, but nothing like the giants they'll become. India continues its backward journey, sliding south across the ocean that will one day be named for it. The continent moves about 2 inches per year in reverse. Doesn't sound like much. But that's the same speed your fingernails grow. And over millions of years, those inches become thousands of miles. Feel the seafloor spreading in reverse beneath India as it travels. The oceanic crust that was created at mid-ocean ridges is being uncreated, sucked back into the earth. The planet is swallowing its own skin, recycling it, preparing to make it again. 70 million years ago, the Himalayas barely exist, just a line of gentle hills where 2 continents are beginning to separate. India is now 1,000 miles from Asia. The Tethys Sea is growing wider between them. What was squeezed shut is opening. What was closed is spreading apart. The limestone that will become Everest is now scattered across a vast seafloor. Some of it hasn't even formed yet, exists only as living creatures swimming in warm waters, as shells that haven't been built, as sand that hasn't been created. The materials of the future mountain are distributed across an entire ocean. You can see India clearly now. It's a huge island continent, like Australia but positioned differently. It's covered in dinosaurs, the last of them. In just a few million years backward or forward in regular time, an asteroid will strike Earth. But that's another story, another breath, another dream. The Tethys Sea is magnificent now, stretching from what will become Spain all the way to the Pacific. It's warm, tropical, filled with life that seems alien to our modern eyes. Sea monsters that paleontologists will one day discover in mountaintop fossils swim through these waters. Marine reptiles the size of school buses. Ancient sharks with teeth like railroad spikes. 80 million years ago. India is racing backward even faster now. Or it seems faster because we're watching such vast spans of time. It's approaching the southern hemisphere, heading toward its original position next to Africa, where it broke away from, or in our backward journey, where it's returning to. The seafloor where Everest's rocks are accumulating or unaccumulating is peaceful. There's no hint of the violence to come, or the violence that's already happened, but we're watching in reverse. Just warm water, gentle currents, and endless tiny creatures living and dying, building tomorrow's mountains, one microscopic skeleton at a time. Feel yourself sinking deeper into this peaceful, ancient ocean, your breathing matching the slow currents, the rise and fall of tides that no human will ever see. You're becoming part of this older Earth, this simpler time, when continents wandered lonely across the globe. Now we're approaching the Great Separation, or in reverse, the Great Joining. India is moving backward toward Antarctica, toward Africa, toward the supercontinent it once belonged to. The Tethys Sea is enormous now, taking up 1/3 of the planet's circumference. 90 million years ago, 100 million. The limestone sediments are younger, thinner. Some haven't formed at all. The creatures whose shells will build Everest are still evolving, still developing the ability to pull calcium from seawater and turn it into architecture. The Indian Ocean is shrinking as India moves south. The mid-ocean ridge that created the seafloor is running in reverse, swallowing its own crust. The spreading center becomes a closing center. What pushed continents apart is now pulling them together. Watch as the entire geometry of Earth's surface changes. Continents drift like clouds, but slower, taking millions of years to move distances you could drive in a day. India is now in the southern hemisphere, tropical but in a different way. Monsoons haven't developed yet. The weather patterns are completely different. 120 million years ago. Can you feel how different Earth is becoming? Or unbecoming? The planet spins the same direction, but everything else is changing. The days are slightly shorter, just by minutes, because the moon was closer, or will be closer when time runs forward again. India is approaching Antarctica now, or what will become Antarctica. Right now, it's not at the South Pole. It's further north, covered in forests, in dinosaurs, in rivers and lakes. The ice sheets don't exist yet, won't exist for millions of years. The collision is about to reverse completely, or rather, the separation is about to unhappen. India is going to rejoin Gondwana, that enormous southern supercontinent, becoming one with Africa and Antarctica and Australia again. The wandering is ending, or beginning, depending on which direction time flows. Feel the massive continental plates grinding, in reverse. The fractures that split continents apart are healing. The cracks are sealing. What was broken is becoming whole. It's like watching a broken dinner plate reassemble itself, each piece finding its perfect fit, each fragment remembering where it belongs. 140 million years ago. The Great Collision has completely reversed. India is no longer an independent continent. It's firmly attached to the eastern coast of Africa, part of Gondwana, part of an even larger supercontinent called Pangaea that's just beginning to break apart, or in our journey, just finishing its assembly. The Tethys Sea has changed shape completely. It's no longer between India and Asia because India is nowhere near Asia. Won't be for another 100 million years. The ocean wraps around the equator, warm and vast and filled with creatures that have no idea their descendants will one day become mountains. The limestone that forms Everest doesn't exist yet. The shells that will create it haven't evolved. The sand that will accumulate hasn't weathered from rocks. Those rocks haven't cooled from lava. That lava hasn't melted from mantle. The entire chain of cause and effect stretches backward into deeper time. Your breathing has become so slow now, matching these ancient rhythms. Each inhale spans continents drifting. Each exhale watches species evolve and go extinct. You're part of the geological clock now, ticking backward in million-year increments. The Tethys Sea is sovereign now, ruling the center of the world, stretching 25,000 miles around Earth's middle. This is the ocean that remembers everything, that holds the future in its waters. Every grain of sand that will one day stand at 29,000 feet is here, waiting, or in our backward journey, returning. See how the water is different from modern oceans. It's warmer, saltier in some places, less salty in others. The chemistry is unique because the continents are arranged differently. Rivers flow from different mountains, bringing different minerals, creating different possibilities for life. 150 million years ago. The Jurassic period flowing backward into the Triassic. The shells that will build Everest are beginning to unaccumulate on the seafloor, each one lifting up, floating back through the water column, returning to the creature that made it. Watch a single shell, just one. Follow its journey backward. It rises from where it was buried beneath 1,000 others. The sand grains that covered it fall away. It tumbles gently upward through the water, defying gravity because gravity runs backward when time does. The shell finds the exact spot where it fell, then continues rising. It approaches the surface where a small creature once lived. The ammonite, that's what this creature is. Like a squid in a spiral shell, it's about to undie. The shell reattaches to its body. The soft tissues that decayed reform, cell by cell, molecule by molecule. The creature becomes whole again, alive again, swimming backward through its life. Can you see how beautiful this is? Death becoming life, decay becoming growth. Every calcium atom that was locked in limestone is returning to the living world. The mountain is unbuilding itself by giving life back to ancient seas. All around, millions of these creatures are doing the same thing. Shells rising from the seafloor, reforming into living beings. The cemetery of the ocean floor becomes a nursery again. The sediment layers thin as their materials return to life. The seafloor itself is changing. The flat, abyssal plains where sediment accumulated are becoming more varied. Underwater mountains appear or disappear, depending on how you think about time. Volcanic islands rise from the depths or sink into them, each one adding its weathered sand to the seafloor or taking it back. Feel the rhythm of accumulation reversing. For millions of years in forward time, shells fell like snow. Now that snow is falling upward, each particle knowing exactly where it came from, following its trajectory backward through the water, through time. 170 million years ago. The tethys is even wider. The shells are more primitive. The ammonites are smaller, simpler. Their spiral shells haven't developed the complex internal chambers they'll have later, or had earlier, depending on your perspective. But it's not just ammonites. The seafloor is covered with other shells too. Brachiopods, like clams but different, more ancient. They carpet entire regions of seafloor, billions of them. Each one adding its small contribution to future limestone. In reverse, they're all lifting away, uncarpeting the ocean. Crinoids, those sea lilies that aren't plants. They're everywhere. Their stems made of stacked calcite discs that look like tiny poker chips. When they die in forward time, these discs scatter across the seafloor, become part of the sediment, become limestone. But now they're reassembling, stack by stack. The stems rebuild themselves. The flower-like crown reforms at the top. The creature anchors itself again to the seafloor and begins to feed backward. 200 million years ago, the Triassic seas. Earth has just recovered from the greatest extinction in history, or is about to experience it as we travel backward. 90% of marine species will vanish or unvanish. Life is rare and precious, or abundant and about to become rare. The shells building Everest's limestone are even simpler now. Some are just tiny tubes. Others are microscopic spheres. but each one is still made of calcium carbonate, the same mineral that makes all limestone, the same atoms that will one day stand at the roof of the world. Watch the calcium itself. Where does it come from? Rivers bring it, dissolved from rocks on land. Underwater volcanoes release it from Earth's mantle. But most beautiful of all, living creatures extract it from the water. They evolved this ability over millions of years, learning to build houses from the sea itself. The first tiny organism that figured out how to pull calcium from water and build a shell. That was a revolution. That single innovation would eventually build mountains, create continents of chalk, form the white cliffs of Dover and the limestone of Everest. 250 million years ago. The end of the Permian, beginning of the Triassic. We're approaching something profound. The ocean chemistry is changing dramatically. The ability to build shells is newer, less common. The future mountains exist mostly as dissolved minerals, as potential rather than reality. Feel how different the ocean is. The pH is different. The temperature gradients are unusual. Massive dead zones exist where no oxygen reaches. Life clusters in certain areas and avoids others entirely. The sea that will build Everest is still learning how to support the creatures that will build Everest. 300 million years ago, the Carboniferous period. The Tethys is younger or older. Time is confusing when it runs backward. The shells are primitive, mostly microscopic. Single-celled organisms called foraminifera drift through the water. When they die, their tiny shells sink, each one almost invisible. But together, over millions of years, they'll form layers of limestone hundreds of feet thick. These microscopic architects never know what they're building. Each one lives for days or weeks, constructs its tiny shell, then dies and sinks. But collectively, they're creating the raw material for mountain ranges. They're writing Earth's history in calcium carbonate. Now let's go even smaller, inside a single microscopic organism. Watch as it pulls calcium ions from the seawater. It doesn't know why it does this. It's just following its genetic programming. But this simple act, repeated trillions of times, will build mountains. The organism arranges the calcium atoms with carbonate molecules, creating perfect crystals. The geometry is precise, mathematical, beautiful. Each crystal fits with the others to form a shell, maybe 1/100th the width of a human hair. Insignificant alone, but when multiplied by countless billions, 400 million years ago, we're in the Devonian now, then the Silurian, the Ordovician. The names of these periods flow backward like the time they measure. The Tethys Sea is almost unrecognizable. It's not even called the Tethys yet. Won't be for hundreds of millions of years. The first shells are just beginning to be common, or becoming less common as we go backward. The Cambrian explosion is approaching in reverse. That moment when life discovered how to build hard parts, shells and carapaces and exoskeletons. All of that is about to be undiscovered. 500 million years ago, the Cambrian seas. This is where shells really began, or where they're ending in our backward journey. The first trilobites are unevolving. Their complex eyes, made of calcite crystals that could actually see, are simplifying, becoming light-sensitive patches, then nothing. The calcium carbonate that will one day be Everest is mostly just dissolved minerals now, floating freely in the water, not yet incorporated into life, not yet destined to become stone. The mountain exists only as potential energy, as atoms that haven't yet learned to come together. 550 million years ago, before the Cambrian, the Precambrian seas, shells barely exist. Life is soft, jellyfish-like, mysterious. The fossil record becomes sparse because soft bodies don't preserve well. The limestone that will form mountains hasn't begun accumulating because the creatures that build limestone haven't evolved. Feel yourself drifting deeper into this ancient ocean. You're breathing so slow now that each breath spans geological eras. You're approaching the beginning of something, or the end, the origin of the sand that creates mountains, the first grains that started it all. We're approaching the first grains now, the original sand, before shells, before life learned to build with minerals. The sand that exists in these ancient seas came from somewhere else, weathered from the first rocks, carried by the first rivers, deposited in the first oceans, 600 million years ago. Earth is a different planet. The continents are arranged in patterns we wouldn't recognize. Most of the land is clustered near the South Pole in a supercontinent called Rodinia, breaking apart or coming together in our backward flow. The Tethys doesn't exist yet, won't exist for hundreds of millions of years, but sand exists. It's always existed since rocks first formed and rain first fell. Watch a single grain, just one, as it travels backward through time. It's been part of Everest. Before that, it was on an ocean floor. Before that, it was carried by a river. Before that, it was part of a different mountain. Before that, another ocean floor. The cycle stretches back and back and back. This grain of sand has been on an incredible journey. It's been buried miles deep where pressure and heat transformed it into solid rock. It's been lifted to the surface and weathered free again. It's been through the digestive systems of countless worms and snails, polishing it, rounding it, making it perfect. 700 million years ago, Earth is experiencing something strange. The whole planet is freezing or melting in our reverse journey. Ice covers everything from poles to equator. Scientists call it snowball Earth. The oceans are frozen under ice half a mile thick. But somehow, life survives, and sand still accumulates in the few places where water remains liquid. 800 million years ago, the ice is gone, or coming. The sand grains are simpler now, less weathered, more angular. They haven't been rolled by rivers as many times, haven't been sorted by waves, haven't been through as many cycles of burial and exposure. Watch the weathering process in reverse. Sand grains growing larger, reforming into solid rock. The rock reassembling into mountains. Those mountains uneroding, becoming taller, sharper, newer. Each grain remembering its place in the original stone. 900 million years ago, 1 billion years ago. The sand is even more primitive. Some of it is volcanic, formed from lava hitting water, instantly shattering into tiny glass particles. In reverse, these particles are gathering together, fusing, becoming lava again, returning to the magma chambers deep beneath ancient volcanoes. Feel how simple Earth has become. The continents are smaller. Most of Earth's crust is ocean floor. The sand that exists is concentrated in small areas, and yet, this simple sand contains everything needed to build future mountains. All the silicon, all the oxygen, all the trace elements that will one day stand at 29,000 feet, 1.5 billion years ago. The sand grains are younger than ever, or older, depending on perspective. They're made of minerals that formed from the first rocks to cool on Earth's surface. These first rocks were volcanic, formed when magma hit air or water and solidified. In reverse, watch these first rocks unform. The minerals separating, the crystals dissolving. The atoms that came together to create solid rock are drifting apart, returning to magma, to the molten interior of a young Earth, 2 billion years ago. Earth's atmosphere is different. There's hardly any oxygen. It hasn't been produced yet by photosynthetic bacteria, or it's been absorbed back in our reverse journey. The sand that exists is different too. It can't oxidize the same way. Can't form the red sandstones we know. The whole chemistry of weathering is different. 2.5 billion years ago, we're approaching something fundamental. The first continents are just beginning to form or unform. Before this, Earth was mostly covered in water with volcanic islands poking through. There wasn't much dry land to weather into sand. The process of making sand requires rock, and rock requires cooling magma, and magma comes from the mantle, and the mantle is made of materials that came from somewhere even more ancient, 3 billion years ago. Most of Earth's surface is ocean and volcanic islands. The sand that exists is black, made of basalt, weathered from fresh volcanic rock. This sand is heavy, rich in iron and magnesium, nothing like the quartz sand on modern beaches. Watch this volcanic sand in reverse, each grain reforming into solid basalt, the basalt melting back into lava, the lava sinking back into magma chambers, the magma descending into the mantle, the entire surface of Earth recycling itself. 3.5 billion years ago, the late heavy bombardment is happening, or unhappening. Asteroids and comets are striking Earth constantly, or lifting away from Earth's surface and returning to space. Each impact that created massive craters and threw out clouds of pulverized rock in reverse. The craters are healing. The debris is gathering, reforming into asteroids that sail backward into the void. Some of the sand from this era is literally stardust, delivered by meteorites, tiny grains that formed in other solar systems, traveled through interstellar space, and found their way to Earth. This cosmic sand will one day be part of mountains, but right now it's returning to space, grain by grain. 4 billion years ago. Earth is young, only 500 million years old. The surface is mostly molten. Solid rock forms and melts and forms again. Sand can barely exist because the temperature is too high. Any grains that form are quickly melted back into lava. But we need to go deeper, further back, to understand where the atoms in sand really come from. The silicon and oxygen that make most sand. Where did they originate? Not on Earth. Earth didn't create these elements. It inherited them 4.5 billion years ago. Earth itself is forming, or unforming in our journey. The planet is accreting from smaller pieces. Planetesimals, they're called. Chunks of rock and metal orbiting the young sun. In reverse, Earth is breaking apart. each piece returning to its orbit, the planet becoming a cloud of debris. These pieces, they're made of materials that formed elsewhere in the solar nebula, that cloud of gas and dust that spawned our sun and all its planets. And that nebula, it was made of materials from earlier stars, stars that lived and died before our sun was born. Let's follow the silicon in a single grain of sand, backward to its origin. It's in Earth now. Before that, it was in a planetesimal. Before that, it was in the solar nebula. Before that, it was inside a star 5 billion years ago. Our sun hasn't formed yet. The solar system is just a cloud of gas and dust, part of a larger nebula, a stellar nursery where thousands of stars are being born or dying in reverse. The silicon atoms that will become sand, become mountains. They're floating freely in this cloud. But silicon doesn't form in clouds. It forms in stars. So we must go back further. 6 billion years ago, 7 billion. Somewhere out there, a massive star is dying or being born in reverse. This star is much larger than our sun, maybe 20 times more massive. It needs to be this big because only massive stars can create silicon. Inside this ancient star, deep in its core, nuclear fusion is running backward. Silicon atoms that were fused from lighter elements are splitting apart, becoming aluminum and magnesium. Those are splitting to become neon and oxygen. The oxygen divides to become carbon and helium. The carbon becomes beryllium and helium. Everything is returning to hydrogen, the simplest element. Feel the immense pressures in the star's core reversing. Temperatures of millions of degrees cooling. The crushing gravity that forces atoms together is weakening. The star is unburning its fuel, unfusing its elements, returning to its original cloud of hydrogen gas. 8 billion years ago, 10 billion years ago. The stars that created the silicon in Everest's sand are returning to gas clouds. Those gas clouds are dissipating, spreading out, thinning into the vast emptiness between galaxies. 12 billion years ago, we're approaching the early universe. Galaxies are younger, smaller, less organized. The first stars are still forming, or unforming. These first stars were different. They were massive, hundreds of times larger than our sun. They had to be, because they were made of pure hydrogen and helium. No heavy elements yet. These first stars lived fast and died young. In forward time, they fused hydrogen into helium, helium into carbon, carbon into heavier elements. When they exploded as supernovas, they scattered these elements into space, seeding the universe with the materials needed to make planets, sand, mountains. 13 billion years ago. The universe is very young now. Galaxies are just beginning to form or dissolve. Stars are rare. Most of the universe is just hydrogen and helium gas, slowly gathering or dispersing, depending on time's direction. The silicon atoms don't exist yet, won't exist for billions of years. The universe must evolve. Stars must form and die. Several generations of them before the elements that make sand can be created. Everything is simpler, more fundamental, closer to the beginning. 13.5 billion years ago. The universe is only 300 million years old. It's dark. There are no stars yet, or they're all going out in our backward journey. This is called the dark age of the universe. when everything was just clouds of hydrogen and helium, drifting, cooling, waiting. Feel the profound silence of this time. No light except the fading glow of the Big Bang itself. No planets, no sand, no mountains. The atoms that will one day stand at the summit of Everest don't exist. The very concept of solid matter is still forming, or unforming as we drift backward. The hydrogen that will eventually fuse into silicon, that silicon that will become sand, that sand that will become stone, that stone that will become mountains. It's all here. But it's just the simplest element, just single protons with single electrons, waiting for the cosmic story to begin. 13,700,000,000 years ago. We're so close to the beginning now. The universe is only 200 million years old. It's expanding in reverse, which means it's contracting. Everything is moving closer together. The vast spaces between galaxies are shrinking. The universe is warming as it compresses. Feel yourself breathing with the universe itself now. Each inhale draws all of space together. Each exhale watches it expand. But we're going backward, so each exhale is really an inhale. Each expansion is really a contraction. The entire cosmos is breathing backward, returning to its source. 13,750,000,000 years ago. Only 50 million years after the Big Bang. The universe is small enough that light from one edge could almost reach the other. It's hot, thousands of degrees. The hydrogen gas glows with residual heat from creation itself. The atoms are simpler. Some of them aren't even complete atoms yet, just nuclei waiting for electrons, or electrons leaving their nuclei in our reverse flow. The forces that hold atoms together are younger, less practiced, still learning how to work. 13,790,000,000 years ago, 10 million years after the beginning. The universe is opaque. Light can't travel freely because it keeps bumping into electrons. It's like being inside a glowing fog. Everything is connected, touching, interpenetrating. 13,799,000,000 years ago. 1 million years after the Big Bang, or 1 million years before it ends in our backward journey. The universe is almost too hot for atoms to exist. Electrons are being stripped away, leaving bare nuclei. The matter that will become mountains is decomposing into its most fundamental parts. 100,000 years after the Big Bang. The temperature is 10,000 degrees. The entire universe glows like the surface of a star. But it's cooling as we go backward, which means it's heating. The logic of reverse time makes everything paradoxical, beautiful, dreamlike. 10,000 years after the beginning, the nuclei themselves are starting to break apart. Protons and neutrons that were bound together are separating. The helium nuclei are splitting into hydrogen. The hydrogen nuclei are becoming free protons. Everything is returning to the primal soup, 1,000 years after the Big Bang. The universe is smaller than our galaxy is now. Everything that exists. All the matter that will become billions of galaxies, trillions of stars, countless grains of sand. It's all compressed into this tiny space, and it's still contracting. 1 year after the Big Bang, the universe is about the size of our solar system. The temperature is millions of degrees. Matter and antimatter are creating and destroying each other constantly, or uncreating and undestroying in reverse. The very fabric of space is unstable, rippling, uncertain. One day after the Big Bang, smaller than Earth's orbit now, billions of degrees hot, the fundamental forces are starting to merge. Electromagnetism and the weak force are becoming one. The distinction between different types of particles is blurring. Everything is returning to unity. 1 hour after creation, the universe fits inside the orbit of the moon. The temperature is beyond measurement. Matter as we know it can't exist. Only a soup of quarks and gluons, the building blocks of protons and neutrons. But even these are starting to dissolve. 1 minute after the Big Bang, everything that exists fits inside the space of Earth itself. The 4 fundamental forces are merging, becoming 3, then 2, approaching the unified force that existed at the very beginning. The laws of physics are simplifying or becoming more complex, depending on how you look at it. 1 second after the Big Bang, the entire universe, all the matter that will become galaxies and stars and planets and sand and mountains, it all fits in a space smaller than our sun. The temperature is trillions of degrees. The quarks themselves are dissolving into pure energy. 1/10 of a second, 100th, 1,000th. The universe is accelerating its collapse or decelerating its expansion. Each fraction of time contains epic changes. The very nature of existence is transforming every billionth of a second, a millionth of a second after the Big Bang. The universe is the size of a city, all of existence compressed into something you could walk across, if walking were possible, if matter existed, if space had meaning at these scales. A billionth of a second. Smaller than a house now. All the sand that will ever exist. All the mountains that will ever rise. All contained in something smaller than your bedroom. The very concepts of size and space are breaking down. A trillionth of a second. The universe is the size of a marble. This marble contains everything, every galaxy, every star, every planet, every grain of sand, every atom that will form Everest. It's all here, compressed beyond imagination. And now we approach the moment itself, or the unmoment. The beginning that's really an ending in our backward journey. Time itself is breaking down. Cause and effect lose meaning. Past and future become one. The breath that started everything is about to be unbreathed. Feel it. The universe taking its first breath in reverse. The expansion that started everything is contracting to a point. Not just a small point, but a mathematical point. No size, no dimension. Everything and nothing simultaneously. This is the singularity, where all the sand that will become mountains exists without existing, where all of space is compressed to nothing, where time hasn't started yet. This is the breath before the breath, the silence before the first sound, the darkness before the first light. And in this moment of perfect compression, perfect silence, perfect potential, something extraordinary exists. The possibility of everything. Every mountain that will ever rise is here in potential. Every grain of sand that will ever form. Every fossil that will ever be lifted to 29,000 feet. The universe is holding its breath, about to exhale in the biggest exhalation ever. The Big Bang is about to happen, or unhappen. But right now, in this impossible moment outside of time, everything is perfectly still. perfectly quiet, perfectly peaceful. This is where the sand that builds mountains truly begins. Not in oceans, not in stars, but in this moment of infinite possibility. When the universe was nothing but potential, nothing but a dream waiting to unfold. Every atom that would become Everest existed here, compressed into something smaller than the smallest particle, waiting. And then, the universe exhales, or in our journey, it inhales everything back into itself. All of creation drawn into a single point. All the sand, all the mountains, all the seas, all the shells, everything returning to the source. The breath completes its cycle. And you know what's beautiful? This cycle never really ends. The universe breathes out, creates stars. Stars create elements. Elements become sand. Sand becomes mountains. Mountains erode to sand. Sand returns to the sea. It's all one breath, one infinite cosmic breath that's been happening for 13.8 billion years. And you're part of this breath. The calcium in your bones, the iron in your blood, they were forged in stars. You're made of ancient stardust, the same stardust that makes mountains. You and Everest are cousins, born from the same stellar explosions, assembled from the same cosmic sand. Every atom in your body has been on an incredible journey. It's been part of stars, part of planets, part of oceans, part of mountains, maybe part of dinosaurs, certainly part of countless other living things. You're not separate from this story. You are this story, walking around, breathing, dreaming. Now, gently, softly, we begin to return. The universe starts expanding again. Time flows forward. The singularity breathes out. The Big Bang blooms in slow motion. Quarks form, protons assemble, atoms create themselves, stars ignite. Generations of stars live and die, creating heavier elements. Silicon forms in stellar cores, gets scattered in supernovas, drifts through space, gathers in nebulas, becomes part of new solar systems, settles onto young planets, weathers into sand. That sand washes into ancient seas, settles on ocean floors, becomes rock, gets pushed up as continents collide, rises inch by inch, year by year, million years by million years, until here we are, back at the summit of Everest, 29,032 feet high, made of limestone, made of ancient shells, made of sand that was once stardust, still rising, still breathing, adding another pencil height of growth each year. And if you're still awake, still floating through these cosmic stories with me, that's perfectly okay. That's beautiful, actually. Sometimes our minds want to follow these ancient paths a little longer, want to trace these infinite cycles one more time. Maybe you'd like to continue this journey. There's another story waiting for you, another gentle exploration of the universe's mysteries. You don't have to do anything. Just let the next story play. Let it carry you even deeper into rest. Your mind might still be seeing those grains of sand, traveling through time, becoming mountains, returning to the sea, and that's wonderful. Let those images continue. Let them blend into new stories, new journeys, new dreams. If you're still listening, still aware, perhaps your body has already found its rest while your mind continues to wander these ancient paths. That's exactly right. You can be asleep and awake at the same time, resting and journeying, still and moving through billions of years. The next story is there whenever you're ready. It'll pick up where this one leaves off, or take you somewhere entirely new. Another mountain, maybe, or an ocean, or a journey to the stars. You don't need to choose, just let it happen. Let the universe tell you another bedtime story. Because you know what? The universe has endless stories. Every grain of sand has traveled through time. Every pebble has been on adventures we can barely imagine. Every atom has a 13 billion year tale to tell. And they're all waiting to share their stories with you, to help you rest, to carry you into dreams. So if you're still awake, that's okay. There's always another story, always another breath, always another cycle of sand becoming mountains, becoming sand. The universe is patient. It's been telling these stories for billions of years. It can keep telling them all night if you need. Just let yourself drift. No pressure to sleep, no pressure to stay awake. Just floating in this space between, where time moves differently, where mountains build themselves from ancient sand, where you're made of the same stardust as Everest. Thank you. Thank you for taking this journey with me tonight, for breathing with the mountains, for traveling through time, for witnessing the universe create itself from nothing, from everything, from possibility itself. Thank you for being here in this quiet moment, for letting these ancient stories wash over you like gentle waves, waves that once built mountains, mountains that return to waves. It's all connected, all one story, and you're part of it. You're safe now, held by the same forces that built Everest, supported by the same physics that turned sand to stone, cradled by gravity, wrapped in space-time, floating in an ocean of atoms that have existed since stars first formed. Let yourself rest now, really rest, knowing that the universe continues its patient work while you sleep. Mountains are rising, sand is settling, shells are accumulating on ocean floors. The great cycles continue, with or without our watching. And that's so peaceful, so freeing. Your breathing has found its natural rhythm now. Maybe it matches the breathing of mountains, that slow geological inhale and exhale. Or maybe it matches the tide, washing sand onto beaches, carrying it away, bringing it back. Or maybe it matches the universe itself, expanding with each breath, creating space for dreams. Everything is exactly as it should be. You're exactly where you need to be, here, now, in this present moment that contains all moments, this breath that contains all breaths, this peace that comes from knowing you're made of ancient stars, built from cosmic sand, cousin to mountains. So rest now, dear friend. Let the stories continue in your dreams. Let sand build mountains in your sleeping mind. Let time flow backward and forward and stop altogether. You're safe. You're loved. You're part of everything. Sleep now if you want to, or drift, or dream, or just breathe with the mountains. Whatever feels right, whatever your body needs. The universe will keep telling its stories. The sand will keep building mountains. And I'll be here, voice fading to whisper, then to silence. But still here, still sharing this infinite moment. Good night, sweet dreamer. Good night, Stardust friend. Good night, mountain breather. Sleep well, dream deep. Rest in the knowing that you're made of the same sand that built Everest. And that's beautiful. That's perfect. That's exactly as it should be. Sweet dreams.